Good afternoon and welcome to the Q&A session 11 from the playlist of NEET Physics. The topic is the energy stored in a system of capacitors, and based on this topic I have one question for this session which is written here on this board. A question very similar to what has been taken for this session was asked in the CBSE All India Pre-Medical Test in the year 2000. So the question here is a capacitor of capacitance C is connected to a battery. It is disconnected when the capacitor is fully charged, and another uncharged identical capacitor is connected in its place. So the energy stored in the system of capacitor is, first option is reduced by 50%, increased by 50%, C remains the same, and D none of the above. So we have to find the correct option out of these four. So here a capacitor of capacitance C is connected to a battery, and the battery is discharged when the capacitor is fully charged. So let us draw one figure here. So this is the capacitor which is connected to a battery like this. So this is the positive terminal of the battery, this is the negative. This is the capacitor and the capacitance of this capacitor is equal to C. So when the capacitor is fully charged, then the energy stored in the capacitor will be equal to Q square upon 2C, where Q is the charge stored in this capacitor when it is fully charged, and C is the capacitance of it. And this is the standard formula, and I hope every one of you must be knowing about it. Now this battery is disconnected when the capacitor is fully charged, and another uncharged identical capacitor is connected in its place. So now the figure will be something like this. This is let us say this is the capacitor. This capacitor is this one, and another identical uncharged capacitor is connected across this capacitor. This capacitor is this one. And another uncharged identical capacitor, that is the capacitance of this is also C. The capacitance of this capacitor is C. So this is connected across this capacitor after removing the battery. So now both these two capacitors are in parallel as seen from this figure. So the equivalent capacitance of this system of capacitors will be equal to C plus C, which is equal to 2C. Now the energy stored in this system of capacitor will be equal to Q square, because the total charge in this system of capacitor will remain the same. So Q square divided by, I will be using this formula, it is Q square upon 2C. Now here the equivalent capacitance is equal to 2C. So this will be equal to 2 into 2C. So the energy stored in the system of capacitors, this is equal to Q square upon 4C. Now from here we can see the energy stored in the first case, that is when this capacitor was connected to this battery, was equal to, that is the energy stored in the first case, that is or we can say initially, the energy stored in this capacitor initially when it was connected to the battery, this is equal to Q square divided by 2C. So from here we can see that the energy stored in the system of capacitor has reduced by half, because this is equal to Q square upon 2C, and the energy stored in this capacitor when it was connected to the battery is equal to Q square upon, so the energy stored in the system of capacitors is equal to Q square upon 4C, and the energy stored in this capacitor when it was connected to the battery is equal to Q square upon 2C. So we can see from here that the energy stored in the system of capacitor has reduced by 50%, or so here the correct option will be A, that is the energy stored in the capacitor will reduce by 50% in this case. So thank you very much for joining this session. In the next session I will be coming up with a different type of a question from the topic of capacitance. So till then, have a nice day. Bye.